Here's your integral to evaluate for this video. You want to pause the video and try it? Go ahead, I'll be right back. We're going to use a trig substitution for this one. You can do it another way, go ahead. Here are the tables we'll be using. For integrals involving this type of radical, the square root of a squared minus u squared, you would use this substitution, u equal to a sine theta. Same thing as saying sine theta is equal to u over a. And know that the sine of an angle, especially the acute angle, is the opposite side over the hypotenuse. And you wind up with this result. After you plug in that expression into the radical, it simplifies to a cosine theta. And you have one over here for the square root of u squared minus a squared. There's your substitution. When you plug into this radical expression here, it simplifies to a tangent of theta. Now for this problem on this video, we'll be using the middle one here, the square root of a squared plus u squared. And we're going to let u equal to a tangent of theta. Same thing as saying tangent of theta is equal to u over a. Or if you're looking at an acute angle for a right triangle, it's the opposite over the adjacent. And that simplifies on the far right here to a secant theta. So let's look at this one here then. So let me just tell you here that in this table, the u is a function of x. So you might have some expression where instead of a u, it's 3x squared or something like that, or 9x squared. So you can make the transformation to u and then change it or make the transformation to theta, or you can go directly from x to theta if you do this here. So in this particular case, so you notice here, we have 9x squared. So I could say, let's look at this as 3x squared in the parentheses there. And of course, it's to the 3/2 power here. So it involves a square root and a cube, power to a cube. So you could say, well, u is 3x. And then we have 16, which is 4 squared. So the a in the formula is 4. And the u would be 3x. But this is what I'm going to do. I'm just going to say, since it's the middle formula, I'm going to use tangent of theta, and that's going to equal to u over a. But I'm just going to leave it as 3x. So 3x over a in this case will be 4. So I get that. And then I can go ahead and solve this, or multiply by 4. So this would give me a 4 tangent theta will equal to 3x. So taking the derivative here, derivative tangent is secant squared, so this will give me a 4 here. And then this will be secant squared theta d theta. And the derivative of 3x is 3, so this would be dx. And remember, I'm trying to get substitutions for the dx so that I can go to the, change this to theta, going from x variable to theta. So dividing by 3 here, dividing the right side by 3, then I get dx is equal to this. And then I'm going to look at this right here now. 9x squared plus 16 to the 3/2 power. So what does that give us there? So notice I have 3x is equal to 4 tangent here. So let's put 3x right there. And that's going to be that's going to be cubed in. So let's look at the square root first. So this will be 16 tangent squared theta. So I'm making a substitution here. For the 3x, I'm replacing the 3x by 4 tangent theta, but then it has a square there. It has a square. So I get this, and then I got plus 16. Now I'm going to factor out the 16, and I'm going to get tangent squared theta plus 1. Remember, this is to the 3/2 power here. So first I'm going to take the square root. Okay, the square root of this right here, let's do the square root of 16 first. That's 4. And then tangent squared theta plus 1, that's secant squared theta. But the square root of that is secant theta. And now let's use the cube. So we took the square root and then we're going to cube it. 4 to the third power is 64. And then it's secant cubed. Now let's go back up here now. So dx is right here. So it's going to put the 4/3 up here. 4/3 right here. Dx is 4/3 secant squared theta. Secant squared theta d theta. And then the denominator we have the 64 secant cube theta. Okay, so this is going to go, this is going to cancel with 2 of these. It's going to leave me 1 here. And then 4/3 divided by 64, invert and multiply. 4/3 over 64 is 1 over 48. So this is going to equal to 1 over 48 here. Simplifying this and this here. And then this is going to go of. And then I'll get 1 over secant here, because this is secant squared is secant cubed. But 1 over secant is the same thing as cosine. So put the cosine up here then. That's theta, d theta. So then this is going to equal to 1 over 48. And the integral of cosine is sine of theta. And then I've got the constant of integration here. But I got to go back to the original variable. So let's just do this here. I'll say the right triangle here. And the tangent of the angle is theta here. Is 3x over 4 on the opposite side. The adjacent side is 4, and then the hypotenuse here is going to be the square root. Using the Pythagorean theorem, square root of 9x squared plus 16. And now we want the sine of theta. So we just look at the triangle here. 1 over 48. And the sine of theta is the opposite over the hypotenuse. So this is going to be times 3x over the square root 9x squared plus 16. And then I got plus the constant of integration. And then we have 3 goes into 48 16 times here. So let's just go ahead and reduce it here. 3 goes into the 48. I'll have a 16 here underneath. So final answer then, we can rationalize the denominator here. I'm just going to leave it like that. X over 16 times the square root of 9x, and that's the square there. I'll make it a little bit clearer here. 9x squared plus 16. Thanks for watching. We'll see you next time.